Wow, hello academicians. Welcome to my channel. Welcome to Master Builders Online Academy, the very online academy where you can learn all the tips as to how you can gain mastery to any calculation course at all. You're welcome, you're welcome, you're welcome. I'm so happy to welcome you to this class. It's going to be mind-blowing. At the end of this lesson, you will appreciate what you will learn from this little time I have with you. Very quickly, before us, we have effects of local attractions and its correction. Basically, this is from survey and it's majorly for year 2 engineering students. Okay, so now we have effects of local attraction before us and its correction. On this basis, now when we say the word effect can be used as an error. It can be said to be an error. Of course, you know what an error is. An error is a deviation from true value, if you can still remember, right? An error is a deviation from true value. So an error is said to occur when the true value or when a value is less than or more than the expected value. Okay, so in this wise, the question before us is, what do you as a student understand by the term effect of local attraction? What do you understand by the term effect of local attraction? Now, let me explain this to you. By what you can see on the screen, we said that the effects of local attraction is said to have occurred when the difference occurred. Okay, now the effect of local attraction is said to have occurred when the difference between the forebearing and the back bearing is less than or greater than 180 degrees, 0 minutes, and 0 seconds. I repeat again, the effect of local attraction is said to have occurred when the difference between the forebearing and the back bearing is less than or greater than 180 degrees, 0 minutes, and 0 seconds. Let me explain this better for your understanding. Now, on the norms, we understand that when you subtract back bearing from the forebearing, or you subtract the forebearing from the back bearing, the expected value it's supposed to be what? 180 degrees, 0 minutes, and 0 seconds. But when you perform this computation of either subtracting the forebearing from the back bearing or the back bearing from the forebearing, and then you find out that what you obtained from your computation is less than 180 degrees, 0 minutes, 0 seconds, it shows that there is an effect of local attraction. Similarly, if what you obtain as your outcome is greater than 180 degrees, then it means that there is effect of local attraction. Then finally, if at the end of subtracting the forebearing from the back bearing or the back bearing from the forebearing, and then the outcome you have is exactly 180 degrees, 0 minutes, and then 0 seconds, it means there is no effect of local attraction. These are the three conditions. When it is less than 180, there is effect of local attraction. When it is greater than 180, there is effect of local attraction. But when it is exactly 180, then there is no effect of local attraction. Remember, I mentioned this effect symbolizes an error. Of course, error is a deviation from true value, and then by extension, an error can either be an addition or a subtraction. All right, so I hope you have been able to understand this part of effects of local attraction. So if this is understood, now let's explain this for your maximum understanding based on these illustrations that we'll have before us. Now, as you can see on the screen, we have, for example, if AB is equal to 230 degrees, 30 minutes, and BA. Remember, A to B is the forward. If we want to relate this in alphabetical condition, A comes before B. So when A comes before B, like we have it now, AB is the forebearing, like we talked about while we're defining the effect of local attraction. While BA is the back bearing. Are you there? Just from Abuja to Benin or Benin to Abuja. So you see now it's a reverse movement. Are you understanding this? So if A to B is 230 degrees and then 30 minutes, then B to A is 50 degrees, 30 minutes. For us to ascertain whether there is effect of local attraction, what we will do is to find the difference between these two values. Are you with me? That's all. So our outcome here will tell us whether there is effect of local attraction or there is no effect of local attraction. Are you with me? I hope I'm beginning to blow up your mind already. Please and please make sure you understand these principles. When you do understand these principles, as I have always told you, you gain mastery easily. So now let me go on. I'll begin to unveil the secret to mastering this part of engineering survey. So now let's go ahead and subtract the least value from the greater value. Okay, 230 degrees, 30 minutes minus 50 degrees, 30 seconds. The answer to this is 180 degrees, 00 minutes. So now, as you can see from what we have here, when we subtract 50 degrees, 30 minutes from 230 degrees, 30 minutes, we have exactly 180. What does this indicate? It shows that for line AB and BA, there is no effect of local attraction. Why? This is because the difference between the forebearing and the back bearing is exactly 180. This is one of the ways to check for effect of local attraction. So as far as line AB is concerned, there is no effect of local attraction. Now let's move to line BC and CB. Are you there? Benin to Calabar and then Calabar back to Benin. You understand that? Also BC, CB, which is forebearing and then the back bearing. Again, what do we do here? We'll simply find the difference between the two values and see what the outcome will become. So in this wise, we will have 297 degrees, 45 minutes minus 102 degrees, 15 minutes. Now, when we find the difference between these two values using a scientific calculator, we have 177 degrees, 30 minutes. So as you can see from this result, you can boldly see now that the difference between the forebearing and back bearing gave us 177 degrees, 30 minutes. 30 minutes. With this, it is very, very clear to us that there is effect of local attraction. Why? Because the expected outcome is 180, but the value we have is less than 180. So because what we have is not exactly 180, it shows that there is an error. This error is what is referred to as the effect of local attraction. Now let's look at the last but not the least. We have line CD and then line DC, as you can see from here. So we have 315 degrees, 20 minutes minus 133 degrees, 10 minutes. Again, when we find the difference between these two values with the help of our calculator, we have 182 degrees, 10 minutes. Again, looking at this particular value or this result that we have from the difference between the forebearing and the back bearing, it is very, very clear to us that this value exceeds the expected value, is greater than 180, right? So because this value is greater than 180, there is an error. There is an error. So these errors are what cause for this correction that you can see at this end, the correction that you can see here. Okay, we have effects of local attraction and its correction. So as we can see now, for line AB, there is no correction because we already have the expected value. But for line BC and CB, we have correction because the value is less than the expected value. While for line CD and DC, there will be correction because the value that we have is greater than the expected value. Don't forget, the benchmark is 180 degrees, 0 minutes, and then 0 seconds. Guys, now that we have discovered that there are errors in these readings or these results provided, what do we do to make corrections to these errors? How do we correct these effects of local attraction? Now let's dive into the basic laws to correcting the effect of local attraction. Now, as you can see here, all right, so as you can see here now, there are basically three major laws. Three major laws. Now, basic laws to correct effects of local attraction. Basic laws to correct effects of local attraction. These three laws will help you effectively in correcting any station where the effect of local attraction is identified. Are you with me? Now, the first thing that we have here as a guide to correcting this effect of local attraction is that correction starts from the station where the difference between the forebearing and back bearing is exactly 180 degrees. Assuming you are given series of results, are you there? You are given couple of results, and then you are now asked to correct the effect of local attraction. What you look out for is a station where the difference between the forebearing and back bearing is exactly 180 degrees. So when you find that point, that is where you start your correction from. So it shows that there will never be correction if you are not able to trace the particular station where there is no correction. So when you are given series of value, the first thing you want to look for is to look out for a station where the difference between the forebearing and the back bearing at that particular station is exactly 180. And what happened? The correction at that point is 0 degrees. I hope you have gotten law number one. Then we move down to law number two. Law number two states that lines that begins with the same station or same letter have the same correction. What it means is, if a line begins with A, I have AB, and again I have AD, for instance. Because the first line started with A and the second line also started with A, they will have the same correction. The same correction is applied to stations that begins or lines that begins with the same letter. Are you there? So if we come up to where we started from, like in this case, it shows that if I have a scenario like this, line BA and line BC, as you can see here, we have the same correction. Are you with me? Line BA and line BC, we have the same correction. Then the same way, line CB and line CD, we have the same correction. Why? Because they begin with the same alphabetical letter or with the same station. I hope this is clear. Finally, the law number three states that correction is either positive or negative. That is, the sign convention is not fixed. What this means is that the error can either be positive or negative. Like we defined before, we mentioned that Error is deviation from true value, and such error is either plus or minus. It's either an error occur by a value less than its expected value or a value greater than its expected value, which is an increase in value. These are what the laws state. So you will not be able to solve problems here effectively without the full understanding of how these laws are applied. I hope you have been able to understand these three laws. Now, having gotten the laws, let me quickly give you the hints and the formulas that will help you understand the calculation process very, very well. Now we dive into the hints and formula, correction hints and formula. How are effects of local attraction corrected? Or how do I get my corrected bearing? Remember, in this wise, corrected bearing is also known as magnetic bearing. Why the bearing you will be given as a question are referred to as the observed bearing. All right, observed bearing. So corrected bearings are obtained from the observed bearing. So understand that observed bearing will always be given. So what you are looking for in while correcting the effect of local attraction is the corrected bearing and then the correction to the corrected bearing. These are the two things you look out for. So how do I find my corrected bearing? This is what we have in equation 1. So to find corrected bearing, all we simply do, corrected bearing is equal to observed bearing plus correction. Observed bearing plus correction. Observed bearing plus correction. Then number 2 is that for us to find correction, remember these are the two things you find. For us to find correction, we'll remove observed bearing from corrected bearing. This gives us equation number 2. Equation 2. Equation 2. Then when we move down to the other aspect of it, we have back bearing is equal to forbearing plus or minus 180. What this means is that if I have gotten the corrected bearing for either the forbearing, to get the back bearing, I simply add 180 or subtract 180 from the known forbearing. And I will tell you the condition to which you add or subtract. Again, if it is back bearing that you know and then you want to find the forbearing, which gives us equation 4 now, we have forbearing is equal to back bearing plus or minus 180. In this equation 4, it shows that back bearing is known, but the forbearing is not known. And understand that the forbearing here are the corrected bearings. All right, are the corrected bearings. Finally, on this wise of equation 3 and equation 4, add 180. Look at the loss now. You see, you have plus or minus. When should I add 180? When should I subtract 180? This is the condition. Add 180 when the known bearing, either the forbearing or the back bearing, is less than 180. So whenever you find out the corrected forbearing or the corrected back bearing that you have is less than 180, to get the back bearing or the forbearing, you add 180. So let me make it straight this way so that you understand it. Take for instance, we already know the forbearing. We want to find the back bearing. As long as the forbearing is less than 180, you will add 180 so you can get the back bearing. Similarly, for the second aspect, you subtract 180 when the known bearing, which is the forbearing in this case now, is greater than 180. So when you find out that the corrected forbearing is greater than 180, to obtain the corrected back bearing, you subtract 180. So while we were solving, we will be using the one I call simple equation. As you can see on this other side, you will see where I abbreviate the formula. CB is corrected bearing, which is equal to observed bearing plus correction, equation 1. Then equation 2 comes as C is equal to CB minus OB, which is equation 2. Then BB, which stands for our back bearing, FB, which stands for forbearing, as the case may be. So while solving problems on effect of local attraction, we will be using this simple formula. I hope you do understand all that I have explained so far. If you have a question to ask, kindly drop it at the comment section below, and make sure you subscribe to this channel if you have not done so. The only way to motivate us to keep dropping content, mind-blowing content like this, is to encourage us by subscribing to this channel, sharing our content, liking our content, and making positive comment about our content. We love you guys. See you in the next question, where we'll be solving problems using all of these principles that we have learned so far from this video. We love you at Master Builders. Thank you, thank you, thank you. See you guys in the very next lesson.